Hello, welcome to my channel. This is the first Elm video in a series of Elm videos. If you don't know what Elm is, it's a purely functional language. It's a front-end technology. It's similar to React, Angular, but it has better benchmark times and no runtime exceptions, supposedly. It also has great interoperability with JavaScript, so you can write your front-end web apps with JavaScript and Elm. To install Elm, you're going to need Node. You're going to need version 10.0.0 or above. And then you're also going to need npm package manager 6.0.0 and above. Now I'm using Visual Studio Code. It's got a great plugin for Elm. If you like another IDE, it's totally okay. I think Adam has a good plugin for Elm too. But yeah, it's just my choice, and it makes it really easy to code in Elm. So the first thing we're going to do is we're just going to create a basic folder. We're going to call this one Elm tutorial, and then we're going to open up our IDE into that folder. This is just a simple way for me to open it up. I'm using git bash. The first thing you're going to do when you have your IDE open is you're going to make sure you have a Elm plugin. The one for Visual Studio Code is this one. It's made by Elm Tooling. At the time of recording, it has 27,970 downloads. It's got a 5-star rating. Great syntax highlighting. It has some bugs in it. It just like destroys my terminal, so I have to reopen my terminal sometimes when I use the Repl. But overall, it is a great plugin. Now, once we're done with this, we're going to actually install Elm. To install Elm, you're going to type in npm install -g, so globally, and then Elm. I already have it installed, so I'm not going to install it again, but it's a really quick setup. Now that we're done installing it, we're going to create an Elm script. We'll use this a little later, but right now we're going to use the REPL just to try out some basic functions in Elm. So to open up the REPL, you're going to open up a terminal. I'm going to expand the terminal here, and you just type in Elm REPL. And then now we have the REPL open, so we can type in a string. So of course, to start off, hello world, and we get hello world back. And it is a type of string. And then we can do simple arithmetic. So 2 + 2 = 4, 2 × 2 is 4. And then, simple power, 2 to the power of 2 is 4. So very basic stuff. And you notice it returns a number. If you want an actual float, it will give you a float back too if you type in 2.7. Now let's get on to some more exciting stuff. So let's just create a simple square function. So square of x equals x times x. And let's test it out. So square of 10 equals 100. Now you'll notice it gave us a function back. It's a number and it goes to another number. So it takes a number and it returns a number. And let's test it out again. So square of 100, 10,000, square of 5, 25. So very basic stuff. To clear the output in the REPL, just type in Control-L. And now we're going to make a new function that takes some argument and it always returns the number 9. So you can see this one actually takes a variable argument. So that argument can be anything. That's what the A stands for. It can be a string. It can be a list. It can be a number. So let's try it out with a string. So my name, Nathan. And of course we get 9 back. And then we can try it out with a list too. So we get 9 back, of course. And then lastly, we'll try it out with a number. So 8. Now let's move on to one of the basic packages that comes with the Elm setup, which is the string library. So if you do string.length, it takes a string and then it returns an int. So let's try this out on, let's try it out on a simple sentence. So, messed up. Nathan was going to the park today. And we get 34 back. Now let's move on to a function that takes multiple arguments. So add a b equals a plus b. And you can see that we get it takes a number, and then it takes another number, and then it returns a number. So the number can be an int, it can be a float. It doesn't really matter. So let's try it with some numbers. So add 10 and 10, add 100 and 100. Now let's try a function with 3 arguments. So a, b, and c, so a plus b plus c, and we get a function that takes a number, it takes another number, and then it takes a third number, and then finally it returns a number. So that's what that declaration means. So we could do add 3 of 10, 10, 10, and of course we get 30. And we could do add 3 of 4, 5, and 100, and we get 109. Now there's one really cool thing about Elm is that if you apply just one argument, so the function actually takes 3 arguments, but if you apply 1, you actually get a function back. So you can see that this function takes a number, and then it takes another number, and then it returns a number. So we can actually declare another function knowing this fact that only takes 2 arguments. So you can see it has the same type signature as the one above it. So you could do add 2, 10, and 3, and you get 17, and then add 103, and you get 107. Now let's do this again. It's called partial application. So we'll just have a function that takes one number and then returns a number. We'll take the function we just made, which was add 2, and then we'll give it an argument, and now we get a function that takes a number and then it returns a number. So we can test this out. So like add 1, 3, we get 17, and then add 1, 1, we get 15. And then add 1, negative 4, so we can have negative numbers too. Now we can also remember our square function from earlier. We can actually build up functions out of functions. So let's use the square function earlier and do a double square function, which is just to the power of 4. So we have square of x. So it takes a number and then it returns a number. So let's try this one out. So just square of 100, we get a big number. Now we can also just set a function equal to another function. So now it's the same square function. So if we use it with 10, we'll get 100 back. Now there is another type of function, which is an anonymous function, which are very fun to use. So to start off an anonymous function, you just type it this way. So you have, it's supposed to be a lambda, but it's a backslash. And then so now we can make a function and set it equal to an anonymous function. So this is similar to if you've ever used Node before, setting like a constant equal to a function and one of the arrow functions. And of course, it takes a number and then it returns a number. So it's the same as our square function, just a different way of writing the square function. Okay, that was it for just a little, a few basic functions in the REPL and installing it.